Now let's see this example. Based on this formal definition, we shall try to decompose this table into third normal form. Now we need not worry whether the table is in second normal form or not. So we'll take each functional dependency and we'll see whether it is meeting this first condition or the second condition. In case if it is not meeting both of them, then there is some problem in it. It might either be partial dependency or transfer dependency. We need not worry about it. Just decompose the table based on that functional dependency, right? So what I mean to say is, see this, assume that this is the example we are solving, okay? Assume that this is the relation given and these are the functional dependencies which are holding on that relation. Now we are supposed to decompose into third normal form, right? Now check this. First check whether it is in third normal form or not. How can I check it? First see the first one, this one. X is a super key, which means left side has to be a super key, or Y is a prime attribute. So we have to take each one and check these two conditions. If any of them is meeting, you leave it, otherwise decompose the table. Now before going ahead, you are supposed to find out all the candidate keys which are possible on this table. Now let me find out all the candidate keys. Now simplest way is see what are all covered in the right hand side of the functional dependencies and mark them C, D, E. Now what are not there in the right hand side of the functional dependencies? A, B. Therefore every candidate key should definitely contain it. So let us say AB. Now let me check if AB itself is enough to be a candidate key, which means if it is going to determine all the other attributes or not. Now if I write AB, it is going to be AB, and since AB is present here and there is a dependency AB determines C, I can add C, and since B is present here and there is dependency B determines D, I can add D, and since D is present here and there is a dependency D determines C, I can write D here. Therefore AB is covering everything, so you can say that AB is the candidate key. Fine. Now this is the only candidate key you are going to get. The reason is AB should be present in every candidate key and it is enough. So if you try to add anything to AB, that will just be redundant and that will make this AB a super key. I mean AB plus that attribute a super key. That is why no need of adding anything. This is the only candidate key in this case. Now let's see. If AB is the candidate key, then A and B are going to be the key attributes and the remaining attributes are going to be the non-key attributes for this table, right? Now based on that we shall verify whether each dependency is going to meet these two conditions, any of these conditions or not. Okay, now let's see the first one. AB determines C. So what is left side? AB, and AB is a super key. Yes, so first condition is it is meeting the first condition, which means according to this functional dependency it is not failing this table to pass 3NF test. Therefore this functional dependency is not a problem at all. Okay, now let's take this functional dependency. B determines D. Now if you see this B determines C, left side is not a super key. Why? Super key is either AB or AB plus something, but here it is not a super key. And what about right side? Right side is not a prime attribute. Why? Prime attributes are only A and B. Therefore this functional dependency is failing these two conditions. So the table is not in third normal form because of this dependency. Now what are you going to do in that case? Whenever you find any such case, you are supposed to decompose the table based on that functional dependency, right? So how to decompose the table? Take the left side of the functional dependency which is failing the case and you apply closure. So what is it? B plus. So what do I get? B plus is going to give me B, and because of this D, and since D is present here and D is present here, I am going to get E as well, right? So these are, I have to decompose the table based on that. So now the table A, B, C, D, E is decomposed like this. B is going to take away with it D and E, which means these two are going to go away with B, D and E, right? And then the remaining is going to be there. So what is the remaining? A, B and C. So since AB is the candidate key for the original table, let it be there, and whatever is remaining you just let them be there. Now after you decompose like this, you have to rearrange the functional dependencies accordingly. Now the functional dependency AB determines C will be here. This is a new table and these are the functional dependencies which are applicable on that. Now what about the other one? B determines D will be on this, as well as D determines E will be on this, right? So now again you take this and you apply for each of the tables. Okay, now if you take this table, what is the candidate key for this? AB, isn't it? AB is the candidate key for this table, right? And what are the functional, so AB, since AB is the candidate key and ABC are the attributes, in this AB are the key attributes, A and B are the key attributes, and C is the non-key attribute, right? Now if you observe this, let's test whether this FD is passing either this one or this one. Now if X is a super key, which means if left side is a super key, then it is passing it, right? See this, left side is definitely a super key. Why? If AB is a candidate key, then AB is also a super key. I hope you remember that. Every candidate key is also a super key, isn't it? Any superset of candidate key is a super key, and every candidate key is a superset of itself. Therefore, every candidate key is going to be a super key as well, right? So now left side is definitely a super key, so it is satisfied, and therefore this table is in third normal form. You can leave it there, so you need not do anything about this table. Now coming to the other side, what is the candidate key for this table? Clearly B is the candidate key, because B plus is going to give you all this, right? Now what does it mean? B is the key attribute and D comma E are non-key attributes, right? So B is the, or you can also call it as prime attribute and non-prime attribute, or key attribute and non-key attribute. B is the candidate key, so B is the prime attribute, and these two are non-prime attributes. Okay, now let's test these two functional dependencies. Now if you take the first functional dependency, let's see whether it is satisfying first condition or not. So X is a, left side is a super key. Yes, left side is B, and B is already a candidate key, and so it is super key. So it is satisfying the condition. So one condition, if it's satisfied, is enough, right? It is not causing any problem. Now if you see the next one, left side D is not a super key, isn't it? Therefore first condition is not satisfied by this one. Let's see at least second condition is satisfied. What does the second condition says? Second condition is about the right hand side. Now the right hand side D is a prime attribute, but it is not a prime attribute, which means first condition is not satisfied and second condition is not satisfied by this one. Got it? And therefore, because of this functional dependency, this table is not in third normal form. So what do you do in that case? Again decompose it. So decompose it in such a way that we are going to find out D plus, and we are going to take away all the attributes which are present in D plus. In D plus you get DE, therefore E is going to be with that, and in the original table B and D will stay there. Got it? Now we got two new tables, and on this table D determines E is applicable, and on this table B determines D is applicable. Now if we again check these two conditions, for this FD, left side is now a super key. Why? Because the candidate key is B. And for this FD, left side is a super key, which means all the three dependencies are now satisfying first condition, right? So what can you say now? Definitely this decomposition, which means if I decompose the table into three tables, this one and this one, finally we are able to achieve third normal form, right? So if you observe it, in this definition or in this process, we never discussed either the partial dependencies or transitive dependencies, right? But whatever has happened can still be done using the partial dependency and transitive dependency definition. If you observe the first decomposition, right, decomposing this table based on B plus, it is nothing but partial dependency. The first decomposition is eliminating the partial dependency, and the second decomposition is non-key and non-key, right? So the second decomposition is done eliminating the transitive dependency. Either you do that way or you follow this definition, anything, both are one and the same. The final answer is going to be the same. So in this process, without worrying about second normal form, we directly dealt with the third normal form. Okay, fine.